Morning, everybody. Thank you for coming out and joining me. My name is Buster Neese, and yes, that is my actual real name. A lot of people wonder that. Buster is my actual real first name. On the internet, I go by Silver Eagle. Feel free to call me anything of those two. One of those two options. You don't call me anything, but one of those two options. So, a little bit of context about me. I'm a web developer, like the rest of you, and I work on a free and open source software project in my free time as a bit of a labor of love. It's a web radio software. I'll talk about it more in the presentation later. But in this project, uh, a couple of years ago, about a year and a half ago, I had a group of developers all come singing the praises to me of Docker. And Docker's the best thing since sliced bread. It's the savior of your local development and your production development processes, everything in between. It's going to make everything so much better. And I was stubborn at first, and I said, no, I've got my shell scripts exactly carved out, exactly the way that I like them, and I've got my Ansible deployment process just as specific and perfect as I want it. But then I gave it a chance, and I looked into it, and it turns out that especially for my use case, it's extremely helpful and extremely effective at producing really predictable, reliable up exactly the way you want them, but they don't match your production environment, or maybe they matched your production environment at some point, and this is the most important part about Docker, is that maybe they matched at some point. Your local script used the same bash script to spin up as your production server did, but since then you've installed stuff on your local server, since then you've installed stuff on your production server, kind of messed with it a little bit. Maybe they're a little different. And what this ensures is that by building off of the same image, they're much more predictable, and you can much more reliably guarantee that an image built from your Docker instance is going to be about the same. It's going to be basically the same no matter what. It also allows for easier spin up for new team members. This is one of the big things that I notice, because I am a heathen who largely develops on Windows. I do a lot of Windows-based development, but I don't actually run PHP on Windows. Because that's painful. Nobody likes to actually do that. But I like the Windows UI, I like the Windows experience, and so I build on Windows quite a lot. And previously, the only option I had was to hope that people used VirtualBox, and hope that they used Vagrant, and that they shared the same VM that I had, and to hope that that VM, when spun up on my host, spun up exactly the same way that it did when they spun it up. So maybe the deploy process wasn't as smooth for me. It really introduced a lot of problems for cross-platform work. Now, if everybody's on a Mac, maybe you don't notice this. If everybody's on a Mac and you're all using Homebrew and you're running directly on the host, well, then you can probably get away with matching your configuration that way. But what this allows is anyone across any operating system and any platform to be able to spin up and run your code very, very quickly without having to understand the intricacies of your specific setup. Once you've learned Docker, that's all you need to do. Is you just need to spin up a new Docker instance. And when everyone's using Docker and everyone's on that same platform, then it becomes second nature, and it's really easy for you to quickly spin up. The other thing is that Docker containers are the foundation of what we consider the containerized web. Technologies like Kubernetes are out there, and you can build Kubernetes clusters based on these Docker images. So when you define this Docker image, what you've done is you've basically prepared yourself to go web scale, quote unquote. I use that very sarcastically, right? Web scale. It's a lot more complicated of an issue that would deserve its own talk, basically, on how to achieve web scale. But one of the big things is being able to separate your application into these concerns, these individual concerns. And when you move to Docker, you do a lot of that as part of that process, and it gets you there. It helps get you there, and it helps prepare you to be operating in a good production environment. So the biggest challenge, and this is the majority of the presentation here, is talking about the Docker paradigm. Because this was what was the most poorly explained to me, I think, as a developer, when my other developer friends said, oh, just Dockerize it. And it sounds so easy, because once you've understood the Docker paradigm and the way that they consider applications built as individual components rather than as one giant VM running everything, once you understand that, it seems like second nature. And a lot of developers that I talked to said, well, just Dockerize it, like it was that easy. The only problem is, if you're used to a more monolithic environment, like, and this is the where we are or where we were, depending on where you are in your current processes. If you're used to a virtual machine, there's a lot of there's a big curve of thought that you have to kind of get over to get to the point where you're comfortable with Docker and where you understand it. But I want to kind of provide some analogies here that will hopefully help with understanding those concepts. So this isn't to say, and the purpose of this slide really is not to say that Docker is the end-all be-all for all local development environments, for all production environments, because it might not be. For some use cases, it might not really be the best solution for your specific use case. In my specific use case, it was one of the best solutions possible, but I've seen some where it really would be a lot of trouble to try to containerize an application. And so the existing setup that we have, largely the most popular setup I see is with virtual machines and then a virtual machine provisioning tool called Vagrant. That's an okay solution, and that works fine. You know, in the pros, of course, everything's in one big honking VM. This is the one big advantage here, is that everything can talk to each other fairly easily. You can install stuff. You can jump into your VM and add new software if you want. You can jump in and run things if you want. You can SSH directly into that VM and make whatever changes you want. And you can use existing infrastructure spin-up tools. So if you're already using something like Ansible, Chef, Puppet in your production environment, you can still use those same things on Vagrant. The cons, however, are that everything's in one big honking VM. It's both a pro and a con, a blessing and a curse in Vagrant's case, that this one giant VM can get out of control. It can quickly deviate from how you initially set it up, and it becomes hard to retrace your steps. This is the big problem that you run into. If you're developing locally and you've SSH'd into your VPN or into your VM, and you've got everything working exactly the way you want, but that's not documented anywhere, then enjoy going back and doing it all over again, trying to kind of guess what pieces you put together to get everything working. With Docker, it's almost enforced. It's basically enforced that all of that has to be in these configuration files that define the images themselves, these Docker files. And so it basically forces you to think about all of your provisioning being something that's committable, something that can be in the repo itself and distributed with the code. And that's a big plus. One of the biggest things that's the initial hurdle into the Docker ecosystem is, how do you separate your application from where it's been running on maybe one VM, or maybe you've run two VMs where one's the database, one's the PHP web application, Nginx, Apache, all of that stacked on top of each other, into each of its separate concerns. And with traditional web applications, this is pretty easy. And so this example here works for a vast majority of PHP web applications that we use nowadays. You could just split it into these same components, and most Laravel apps, most Symfony apps, most WordPress, Drupal type apps, they'll all run fine within this setup, provided you haven't done anything fancy. Which is, if you take the components, your database, you take your web server, you take the PHP application itself, and you take maybe a cache layer. You got Redis, you've got Memcached, something sitting in the way, something offering caching there. You take those and you think of them as separate components. Most of the time, you're probably going to be good to go. But you've also got to keep in mind if there's anything else that you're depending on. So in my case, for my application, there are about 3 or 4 more things on that left side, that virtual machine side, that I had to think about splitting up that didn't initially occur to me. So there's things like InfluxDB. It's a time series database, really common for statistics management. I had to think of that as a separate component and figure out how, if that were a separate component, it would talk to the other components here. So this is the other thing here, which is you have to picture each of these components as being on, essentially think of them as if they're running on their own server. Basically, that's the easiest way to think of it, although really they're not. They're all running basically on the same server in different little containers, but think of them as if they're a world away and you have to communicate with them only via, let's say, TCP/IP, which is pretty common on these Docker containers. That's another big hurdle, and maybe not something that your application is set up to do initially, but that's one of the biggest things to get you ready for moving into Docker, is to think about splitting the application up into these concerns and then making it so that these concerns can talk to each other without sharing direct file system access, without being able to just write files to one another. Maybe they need to have some sort of API by which they can talk to each other. Your database already is covered on that. Your database can already accept, odds are very high that it can already accept TCP connections. Nginx and Apache are already set up to handle this via FastCGI, for example, and PHP is set up to handle this via the FastCGI Process Manager, FPM, and caches are set up. Redis is set up already out of the box to accept these TCP/IP connections. So again, if you use this common setup, this is a lot less work than it looks. So one of the, and this is, all right, Rick and Morty people will possibly appreciate my metaphor here, because this is one of the best metaphors that I could think of to describe what a Docker container's purpose in life is. Right, so a Docker container, if you remember Mr. Meeseeks from Rick and Morty, Mr. Meeseeks, and just to summarize for if you're not familiar, Mr. Meeseeks is a being that sort of poofs into existence, has one sole function to do, and then when that job is done, it disappears, and it's gone. And, you know, let's forget the whole existence is pain side story of the Mr. Meeseeks characters, but really, if you think about, you know, I have one job to do and I'm going to do it, and then when it's over, that's it. It's gone. That's what Docker containers are. And a Docker container is very much this ephemeral thing that runs and that serves one purpose, and this is the Docker way, is to think of things as basically being one command that runs per container. So again, if you go back to this setup, this previous setup here, where each of these things is separate, well, all right, so MySQL server, well, that's one command. Nginx is running, well, that's one command. PHP FPM is running, Redis is running. These are all one command, and so thus they translate into one Docker container each. And they really shouldn't be together in the Docker way. If you're following the Docker philosophy by the numbers, then these things don't share the same container. Basically, each container has one command that it executes. When that command executes, and it finishes, then the container exits. Well, what about daemons is the next question. So what about daemons? Well, daemons don't really exist in this infrastructure. And I know there's an asterisk there that says, yeah, they kind of sort of do if you hack it around. Yes. Think of it as though they don't, though. And every program that runs in demonized mode, almost every program that I can think of out there, has a flag that you can set that says run in the foreground instead. Nginx has this, PHP FPM has this. Instead of using systemd to run, or some other better orchestration system to run the process, you can just have it run in the foreground. And this is what you should do if you're building Docker images. And if you're using the Docker images that are already out there for Nginx and PHP, that's already done for you. They've already set all of this up using the Docker mentality. They're already 10 steps ahead of you. So this is the, that's what I'm going to get to here in a bit, but the other good thing is a lot of this is already kind of thought out for you in terms of the distributable images that Docker already has out there on its registry and on its hub that you can just pull down and use today on your application, basically unmodified. So a command in this case is anything that you would consider one bash script command, effectively. So if you're thinking, I could chain together a whole bunch of things into one very long bash script, that can also be the one thing that Docker does. It can be big, it can be complicated. There's a special way of denoting how you do it, but that's not all that important. But really, it just has that one job. If you absolutely need to, and I put this one note in here because even I deviated from this initially, and I still do, because there was just one process where the software I was using couldn't communicate, and it can't communicate over TCP/IP to one another. And they needed to be on that same box talking to each other via sockets, basically. They needed to be very close to one another. And if you need more than one process running, there are a bunch of different tools you can use, but one of the ones that I recommend that I've played with a lot is called Supervisor. Supervisor is a Python application initially. They've also made a whole bunch of different forks for it in Go and everything else. But what it does is it basically does the job that like systemd does, for example, except it does it with these foreground running processes that always run, and it exposes this really nice API under the hood that allows you to control those processes, to turn them on, turn them off, reload the configuration dynamically. It's all really powerful under the hood. But if you absolutely need to run more than one thing in a Docker container, you can do this instead, and you can say the one thing I want to run is Supervisor. And then Supervisor says, okay, well, I've got 10 things I want to run. That's okay. You can do that. It can the processes can inherit from one another. It just needs one parent process, one main process that runs, that ends, and that when it ends, that's the end of the container. But that process can be something that runs other processes, just like supervisor. So one of the biggest assets that's available to us when converting an application to Docker is the work that's been done already by a number of people to produce, and a lot of these, by the way, are actually built by the companies that make this software. They've embraced Docker so heavily that they're actually building these Docker images directly off of the Git repositories for those code bases, which means, you know, they know everything about how this software should run in Docker, and they've got it all figured out. And they've basically built these images for you, and you can pull them directly from the Docker Hub. And a lot of them have documentation. If you actually go to Docker Hub, you know, you type like Docker Hub Nginx into Google and search for it, you'll see a big set of instructions, and they've got some specific setup about how they want you to configure it. But a lot of the time, you just point your code at a certain directory inside of that Docker container, and it'll run, no problem. In the case of PHP, they even have containers that, while they do somewhat violate the one thing rule, there are containers that contain both Apache and PHP running together in one container, so that basically, if you're not connecting to a database, you can run your entire application inside one container. If you're connecting to a database, you can run it in two. But that's actually built and officially supported out of the PHP library. And if you're a PHP developer, there are also Docker images that are specifically built with the necessary PHP extensions, with the necessary customization, in order to run WordPress, Drupal, Magento, MediaWiki, etc. All of those that I listed there have unofficial, except for Drupal, which I believe may be official, actually. Drupal does have a Docker image, but all the others have unofficial images that you can find that other developers have built that are either all you need, or they're a really great jumping off point to build your own images on top of them. So this is speaking of rolling your own images, this is one of the big concepts that defines what Docker is and how to build these Docker files. So again, like I described earlier, think of a set of blueprints that are all stacked on top of one another, and that whole stack is just crunched down and then delivered, and that's your container. Your container is the sum product of all of the different little blueprints that have stacked up. Well, each of those is a layer on this image. So the image starts with nothing. That's that from scratch, and I'm using the Docker file syntax here just to kind of ease into the way that Docker files are written. But if you look at kind of how my PowerPoint or how my slideshow bullet points go, that's also how things are inherited from one of these images to another. So from scratch is where everything starts. That's an image with nothing on it. So nothing is running at all. The operating systems have then come out with their own images that basically give you a very lightweight version of that operating system inside of Docker. So Debian has come out with it. Ubuntu has come out with them. And Alpine is one that I'll talk about here in a bit, is specific to Docker containers and is very optimized for Docker containers to be very lightweight. But basically, what they do, and this is important to note here, is there's two aspects of this, right? So each of these from not only has the organization that, you know, the actual repository name, so in these cases Debian or Ubuntu or Alpine or PHP, but also has a tag for which version it's using. So in this case, you see both of these, PHP 7.2 Stretch and PHP 7.2 Alpine, both start with PHP and are both manufactured. They're both generated automatically by the same organization, by the same PHP repository, but they target two different operating systems and are really two very different images. And the way that they distinguish these is tags. So these are all tags that are associated with each of these. Now, the one go-to tag that you'll see very, very often is latest. Latest. You'll see latest a lot because latest is essentially the equivalent, think of it like get master. And a lot of the time it's directly built off of get master. In fact, that it is just the latest with whatever stability concerns there are involved in that. And this can be great to test with. You can always test with Alpine latest. But I don't really recommend using it in any sort of production environment because what latest is, much like building, if you're on Composer, it's like building off of dev master. That can change from moment to moment. And unlike Composer, Docker pulls down the latest version whenever you go to pull, and whenever you go to build a container, it'll try to pull down the latest version. And it doesn't have any way of locking it to one specific version unless you lock it to a specific tag instead. So that's very important. So if you're used to dev master and you think, oh, it's fine because I have to run Composer update manually in order to pull it up from whatever version I'm on, don't count on latest being as stable in this case. So if they have tags, if you have an image that has specific tags like PHP 7.2 or 7.2.1, even better, you have the more specific you can get, then the more reliable that image is and the less likely it is to change out from under you. So again, this is another depiction of how Docker images are structured. So each instruction in the Docker file basically creates what's essentially a new layer. And the first thought is each of these instructions, so let me back up. Each instruction is basically like a bash script. Again, most of them are like bash scripts. Some of them are changing the working directory or exposing ports or things like that. But most of them are just the word run in all caps, followed by what would normally be considered a bash script. So each of these forms its own layer, and the advantage of this is that these layers can then be cached. They can be optimized. So let's say you want to build a Docker image that's based on one that already exists, and you just want to add a couple of little things on top of it. Well, if you've already got that other image, then it already knows all of its layers. And all you're doing is just adding new layers on top of it, so it's a lot faster. And it can do that a lot quicker and without occupying as much space as if each of these were to be sort of standalone images. They're all based on top of each other. So it's a way of saving space and a way of optimizing how, if you have 20 different images sitting on your system, they can all share a lot of common layers, and thus they can save a lot of space. The top layer, the very topmost layer, is what the container runs on top of. So basically what you're doing is you're building and defining the file system. Each iteration of this layer, you're customizing things on the file system, whether you're installing software or whatever. What you're really doing is you're just writing changes to this file system and it generates this new layer. And the very top layer is what the container actually runs in. And this is just built right. This is just a thin little layer on top of all of these images. And one of the most important things to remember, and I'm not sure if it's my next, no, it's not. Okay, one of the most important things to remember is that when the container ends, when it stops running, that thin read-write layer at the very top, it vanishes. It's gone. It goes with the container. So when it stops running, you can't really count on that being there anymore. And so what you have to do is you have to make sure that anything that needs to be persistent across multiple Docker images or multiple Docker containers needs to be in the image itself. It needs to be defined in these hard-coded layers underneath it so that each time the container is spun up, it's already there and ready to go. So here's an example, super simple Docker file. I apologize if it's a little small, but it's just one of those things. So at the very top, we have the from, and what the from is stating is where it's inheriting, what image it's building on top of. So in this case, we're building on top of Ubuntu 18.04, which is tagged under the Docker Hub as Ubuntu Bionic. And that gives us a fully ready to run 18.04 LTS instance of Ubuntu on top of which we can just do whatever we want. Maintainer, it's not necessary for you to specify. But then the real meat and potatoes of the Docker file is going to be these run commands. And if you notice what's going on here, this is very important, and when you're building a Docker file, it's good to do this. But if you notice what's happening here, you see the ampersands joining multiple commands inside of one run command. If you were running a bash script, for example, that wouldn't be all that necessary. There's really no reason or benefit to doing that. But when you do a Docker file, each of these run commands creates one layer on top of each other layer. And so what you don't want to do is unnecessarily create 20 little layers. And so if you were to do run apt-get update, run apt-get install, run apt-get clean, if you were to do each of those separately, what you'd do is you'd create one layer that installed the software, or one layer that updated it, one that installed it, and then one that cleaned it up, but it wouldn't optimize correctly. It would just stack them on top of each other, basically. What this does when you chain the commands together is it says the end result of all of these commands run together should be its own layer. Should be one layer. So that's what allows you to do, and this is a little out of date. It's a little anachronistic, actually, because nowadays when you're building Docker files, especially with Ubuntu Bionic and with Alpine, the Linux version that's specially built for containers, it kind of does a lot of this for you, this cleanup here. Like, you don't really need to run apt-get clean anymore. They kind of do this for you, but it's just an example of why it is that there's this tradition to chain a whole bunch of run commands basically together in one single run command like that, and what that achieves for you under the hood. A lot of the time, and for the sake of space here, I didn't do this, but a lot of the time you'll see you can wrap those onto separate lines, and you can actually have each of them be its own line all the way down, provided that you use that / operator at the end of each line to just indicate to the shell executor that it's continuing on to the next line. The next command there is establishing an environment variable. This is another big jump into the Docker ecosystem, and perhaps one of the most significant ones if you're building an existing application and you're moving it into Docker. One of the most significant things is environment variables are your friend. They are the way that you send specific settings that change from environment to environment, your database password, your base URL for your APIs, a lot of things like that can be sent over as environment variables into the application so that each time it spins up the container, it's got its own individual set of those, and it can just call on those variables internally. So I want to talk about environment variables a little bit more here in a second, but those are your friend. So expose 80, now what that does is it says this container has a outward-facing port 80 listener, basically. It can accept connections inbound on port 80. Now, that doesn't necessarily mean that on the host, for example, so you got to think each container is running inside of one big host machine. It doesn't necessarily mean that when you hit the host's port 80 that you're going to be hitting this container, because there's a little layer in between. There's a proxy layer in between that lets you determine where port 80 here goes on the actual host, what port it actually corresponds to. So you can change the latter. You can change where it is on the host without needing to change the actual definition here. And then command. Command is that's the one thing it does. That's the big thing at the very end. There's this is what I was talking about, that unique style of actually indicating the command where it's all in brackets and each thing is separated by a comma. But think of it as if they were just separated by space, because that's really what it would be if it were a bash script. It would be, user sbin apache2 space -d space foreground, and that would run it in the foreground. It de-demonizes it, basically, so that it directly returns to the foreground, and what Docker does is it sits there and runs the foreground, basically, and waits for it to either just run forever, and it can run forever, or for it to stop. So if you're building containers that all depend on an installation of Ubuntu or an installation of Debian, they have this tendency to get kind of big. And a lot of the time, maybe one image doesn't matter. Maybe if your one image is on PHP, it's not a big deal. You know, it's on Ubuntu. It's not a big deal. Maybe if it's only occupying a small amount of space on your computer, really not much of a concern. But when you have multiple images, again, if you're doing Docker quote unquote the right way, and you're splitting it up into Nginx, MySQL, MariaDB, Redis, and PHP, now each of those is its own little, and let's say 300 megs. You know, let's say 100 maybe, 200 maybe, 300 megs of an image for each of these. Well, it adds up. It adds up and it takes up a lot of space, especially if you're running a local dev environment and you're rebuilding these images over and over. It can take a lot of space. So what has come out is Alpine Linux, and this is one really cool thing that may work for your PHP applications and is especially recommended now because Alpine has just recently come out with a stable image that contains PHP 7.2. So if you want to take advantage of all the new hotness that's in PHP 7.2, you can do that with Alpine Linux now very easily. But the advantage is it starts at 3 megs. Unlike 100 megs or 300 megs, the base image here, 3 megabytes, just a super tiny little thin layer just on top of the Docker thing. And it's optimized for running in a container. That's its whole job in life. You can run Alpine Linux on an actual host if you wanted to. Not a lot of people do because it's really thin. It's really lightweight. It's bare bones essentials. One of the big things, and for PHP people, yeah, you probably won't care. For a lot of other, like if you're running a compiled language, this might matter. One of the things it does to save that space is it switched from glibc, which is what your Ubuntu's and Debians will have to compile C applications, C++. I don't remember which, both? I don't know. I don't really do that kind of stuff. But they switched to Musl, M-U-S-L. And it means that there may be some challenges in cross-compiling applications that need to be built from scratch. A lot of applications can still be built in the Alpine environment despite this, but some can't. And sometimes it's just kind of a deal breaker. But for PHP extensions, it's not really a problem because PHP extensions are already pre-built binaries that are available via Alpine's APK app storage. It's basically the same thing as apt-get, you know, their package manager. And a lot of those 7.2 extensions are already built. And so you don't have to worry about any of those intricacies under the hood. You just do APK add the thing. But Alpine, if you're playing with Docker, Alpine's definitely something worth looking into. Big, scary orange thing. Remember, containers go away. This is one big paradigm shift that's different from like your VM. So you turn off your VM, you turn it on the next day. Everything's still there exactly where you left it. Well, not always the case with Docker. You stop a Docker container, you spin up a new one. Well, it's based on the image, and the image is still there, but the container is different. So you have to remember that containers are ephemeral by nature, which brings up the question, well, where do you store stuff? Well, this is already something if you've scaled up to a multiple server environment on your production environment, this is already something you've had to consider because multiple PHP servers calling on the same data, they already have this consideration. And so we've kind of already solved this problem in a bunch of different ways. Either you can share a flat file database between them or a folder, basically. You can share a folder between each of them, which I never actually got around to explaining volumes. I guess I have to explain volumes too at some point. But forgot to put that slide in. Whoops. But yeah, you can mount a folder from the host into the actual Docker containers as a volume. So this is good for development too, especially if you're on a local computer and you don't want to constantly be pushing stuff up to the Docker thing, to the Docker container. You can mount the folder that you're working on your host computer inside the Docker container and have it actually refer to a specific Linux path like, you know, var www inside of the container and have that be different from the actual path that it is out on your host. So you can share that. It's not really particularly recommended for production environments, but you can do that. Databases will also solve this problem. If you have databases that multiple PHP instances are communicating to. Provided it's communicating to the same database, then that database is persistent across everything. So you can store your sessions and other persistent data inside the DB if you want. There's, of course, all the usual performance overhead for doing that. Or you can use a dedicated cache. That's definitely the one I recommend, and that is to use something like Redis or Memcached to serve as an intermediary layer that is a high-performance, speedy cache, but that can persist across instances. So even if PHP goes away, then that cache is still there. And that cache can write to disk even and persist. So there's a handy little library, and this is kind of a non sequitur to the Docker thing, but this library called Stash, if you haven't heard of the library called Stash, it is a really neat thing, and that really helped me with abstracting out a lot of the caching concerns in my application, because what it does is it's basically a database abstraction layer, but for caches. And it allows you to specify multiple levels of caches and have them cascade accordingly and stuff. So if you haven't already checked it out, worth checking out for sure. Yeah.
To clarify on here, if you got a database or cache, you still have to volume mount that into somewhere. Otherwise, if you're
correct, yeah.
You run RM, your database server, that didn't stop your database server, then you just lost your database.
Right. Yeah, you have to have persistence somewhere. Yeah, so, sorry, and I didn't mention that there, but yes, the database does have to also connect to a volume somewhere. And since I don't mention it anywhere else, that is an important thing that, actually, I do in the, never mind. Okay, sorry. Train of thought. We're back. One of the big things that helps with migrating, and if you're like me, my environment has both VPS customers. So I'm building a piece of software that's self-hosted. And you can host it either directly on a VPS, like DigitalOcean VPS if you wanted to, or you can host it inside of Docker containers. But I support both. And one of the ways that you support both is by using environment variables, and then using, if you don't have a Docker-based environment that automatically passes those environment variables into the PHP for it to consume, then you can use a library like .env, which is from the Symfony collection. That will allow you to pull basically literally .env. It's .env is what it is. But it basically mimics passing in environment variables. So the environment variables can be passed in either from one big Docker run command. They can be passed in from Docker Compose, which I'll talk about here in just a second. And they can also be in .env at the project root. That's a specific little Docker hack there. And there's one big caveat here, and this is one thing for the PHP people especially. If you get into Docker and you find that your environment variables aren't in there and PHP is not seeing them, this is the first thing I ran into. And it baffled me because it wasn't really well documented anywhere. But there's a setting, and even PHP's own Docker libraries don't change this. By default, PHP FPM counts on environment variables being sent from the web server, Nginx, Apache. It counts on environment variables being passed over, and it clears out any ones that exist in PHP itself. On wherever it's running, and it does. There's a lot of good reasons to do that, but in this case, it kind of breaks everything, unless you're specifically passing over all the environment variables. Well, there's only one thing you need to do, which is set that clear env equals no. Which, by the way, I don't know if I mentioned this, but all the slides will be on Slack here later. So, all the code and the links and everything else will be much more useful when you're actually looking at it on a computer. So, yeah, all of those will be shared right after this in the Slack group.
That's a great tip, by the way.
What?
Clear env.
Oh yeah, clear env equals.
One of those things that
It's a little thing, but it'll catch a lot of PHP people. And if you say clear env equals no, PHP gets the environment variables sent to the PHP container, which is probably what you wanted to begin with. So, yeah, very important. Huh?
in a container,
Yeah.
never the other way.
What?
Don't ever do that not in a container.
Oh, yeah, don't ever do that not in a container. If you're in a container, this will match your expectations of being able to send things directly into the PHP container instead of having to send them via the web server. So there are tools that help make this whole process easier. The first thing I want to mention is that Docker is itself cross-platform and installable anywhere, basically anywhere. There's native support on CentOS, Ubuntu, Debian. Nowadays, it's split into Enterprise Edition, which costs money, and Community Edition, which is good for people like me who don't have money. The packages are often named Docker CE. It used to be just called Docker, but nowadays a lot of the packages you'll see is Docker CE. That's Community Edition. That's probably what you want for local development and to play with stuff. For Ubuntu, you'll have to install a PPA to get the latest version. There are full instructions on Docker's actual website about how to do this. It's 10 lines of code that you have to do. But Docker for Linux is very high performance and low overhead, as you would expect. If you're running a Linux host, then Docker just sits right on top of it. It integrates in with whatever Linux host stuff you're already doing. And this is the very fastest possible way that you can be running Docker, and it's excellent and highly recommended. Now, if you're on Windows and Mac OS, it has to virtualize out somewhere because Docker has to run on a Linux host, and you're not running on a Linux host. And so there are different ways that it accomplishes this. So Docker for Windows uses Hyper-V, which is required. It requires that you use Hyper-V. I'm not terrifically happy about that, by the way, because Hyper-V is a Windows 10 Pro only feature. If you have Windows 10 Home, you're out of luck. You can't use that, which means you've got to use the older Docker toolkit to develop if you don't have Windows 10 Pro. But Docker for Windows is newer. It's more advanced. It has built-in Kubernetes integration out of the box. Kubernetes is a container orchestration tool that is basically one step above Docker. So once you've Dockerized everything and you want to scale that out into a mass infrastructure, multiple servers, Kubernetes is one of the great ways to accomplish that. Docker for Windows also has some known issues. Since I'm a Windows-based developer, that was a bit of an understatement there to just put some known issues on that slide. I'm being generous to them because they are also an open source project. I know that they do the best they can, but there are some issues. Namely, if you reboot, everything's gone for some reason. All your volumes go away. You have to shut down all your containers and start them back up. It's a known issue. It's been a known issue for about 2 years. Whatever. Anyway, they'll work on it, I'm sure. Docker for Mac OS. What? Yeah, thankfully you don't have to reboot Windows. Oh. Well, Docker for Mac OS is suspiciously so much better that it makes me think all the Docker people must be running Macs. Suspicious. That or Linux, right? You know.
I have heard of people who had problems who tried to, do the portability thing that, they developed it on Mac and, when it went into production or running on Linux, then it's like, there was...
With Docker?
X-Hive, yeah.
Oh. That's kind of uncommon, honestly, because a lot of it is basically so abstracted out from the actual Docker containers that really Docker doesn't know or care that it's running in Windows or running in Linux or running in Mac OS. That's the ideal world, right? Is that it doesn't know and it doesn't care. It's just running. It's Docker. It's its own little container. But Mac OS is built on top of their native hypervisor API and X-Hive. I'm not sure if those are exactly the same thing or if those are just different ways of referring to the same thing. I haven't used a Mac in a while because I don't have $2,700 spare dollars. So, Mac users, though, you'll find it to be a very fluid experience. And they even have a little tray icon at the very top that shows you the status of it. So does the Docker for Windows. But Docker Toolkit is the legacy version for both. So there's a Docker Toolkit for Mac and there's a Docker Toolkit for Windows. It uses VirtualBox. So this will run on anything. It'll run on Windows 10 Home. It'll run anything you want. And it includes Docker Compose and other cool stuff. The only caveat is it's slow. It is really, really slow. Call it VirtualBox's fault. It may be VirtualBox's fault. It probably is a little bit. But it's slow and it's really hard on your battery. So only use Docker Toolkit, the old one, if you really have to. If you can, use the newer Docker versions. So there's this other script called Docker Compose. It was originally called Fig when it first started. It's a little Python utility script, and what it allows you to do is to describe multiple Docker images and how they interact with each other, how their networks are connected, how the volumes are connected, and basically everything you need to configure about a Docker image in one giant YAML file. This Docker Compose YAML format, and this YAML format is super pleasing to work with. It's very easy. And really, it turns, like I said in the slide, it turns what could be a 40-line Docker command of, Docker spin this, connect this, do this, that, into a YAML file that you can then commit into your repo, and that'll allow you to run a application very easily that uses multiple Docker images. A lot of PHP applications are going to be applications that use more than one Docker image or more than one container. And so this is a lifesaver. Don't play with Docker without playing with Docker Compose if you're running more than one Docker container at a time and trying to get them to talk to each other and to be networked. The link's there in the bottom on how to install that. It's just a Python script, but it comes pre-installed with Docker for Windows and for Mac, and you can install it by itself. So this is an example Docker Compose YAML file. It doesn't normally wrap onto 2 lines. I'm just doing that for the sake of saving space here. For the sake of being out of space. It's already kind of small as it is. But this is just an example, right? So you see the services configuration configures each container that runs. So you've got a database service, you've got a WordPress service there on the right, and each one can be set. It's all the settings are right there. All the configuration is right there. So the image that it's built on, volumes that are mounted to it. So in this case, like Ian was saying, if you want to have a database be persistent over containers, you have to mount a database, or you have to mount a volume in there for it to persist that data. Well, this configures how that's mounted and where it's mounted. Also configures things like when the host reboots, does the container reboot with it? In this case, always. It sets environment variables, and in the case of WordPress, you can see where it does that port mapping. If you see that ports 8000:80 over there, that's the important thing. That's what I was talking about earlier, is even though the Nginx container may say I listen on port 80, it doesn't mean that on the host you have to be listening on port 80 as well. You can configure that, for example, here. And what that says is on the host, if you hit port 8000, it's going to go to port 80 in the container. And there's a little thin userland proxy that just sits there and shuffles all that traffic back and forth. It does that really fluidly. You don't really, it doesn't occupy that much in the way of performance. But that allows you to do, like if you're on a local machine and you've got more than one instance, you can have port 8000, port 8001, port 8002. And they can each correspond to port 80 in their containers without you needing to change the container at all. The container still thinks it's being connected to on port 80. This is a big plus, and allows for easier development. And there's a lot you can do with this. Now, there's this new thing that I played with for the sake of this presentation, actually. I wanted to play with this so I could describe it here, and it's Docker app, which basically takes this cool stuff you can do with Docker Compose here, where it can define all these services. It lets you take all of that, and package that up as if it's one big application, and then distribute that out to everybody, which that's exactly what I want to do. What I build is a self-hosted application, and I want people to just be able to pull one single configuration and have everything ready to go. This is what the promise of Docker app is. This is a brand new thing that they're experimenting with, and it is really still very experimental. That's all I'll say about that. It is still, it's not done. They're still working on it. But basically what it lets you do is it lets you create a .docker app file, which goes one step further than Docker Compose. So not only does it have the Docker Compose service configuration in it, but then it adds in environment variables and settings and then metadata for the project. Basically everything you would need to distribute all in one. It works directly with Kubernetes, so if you're using Kubernetes on production, you can have it generate Helm charts, which are a Kubernetes-specific thing for you, and it's really neat. The only problem, at least in my case, is that Docker apps depend on Docker Compose version 3 or better, which, if you haven't played with Docker Compose, it's a little complicated. Docker Compose version 2 and Docker Compose version 3 are a little bit different, but in kind of an important way. And it doesn't really matter for everyday use, but the only version that they use here is Docker Compose 3. I'd give them a little bit to kind of work out the kinks in that. But anyway, it's a really cool idea, and the prospect of this is that instead of pulling down Nginx, MariaDB, Redis, blah, 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 you can just pull down WordPress. And you pull down one built WordPress Docker app, and it's got your database. It's got everything configured separately as separate containers. You just pull it down once, configure your environment variables, and you're good to go. That not only lowers the barrier to entry for people getting into Docker, but it makes it easier if you're distributing something that people can host. And there's another thing, if, again, like me, you are the heathen type who doesn't like to play in the command line all day, there's a GUI that lets you manage Docker. It's called Kitematic. It's a little old now, although I believe they are still maintaining it. But it's a really neat little GUI for Windows and Mac. And what it allows you to do is view all of your running containers. You can spin them up, spin them down, view the volumes, etc., all from a nice, clean UI. Takes out all the Docker-ness of it all, right? So Docker, by default, is a very command line interface heavy application. So you got to kind of know how to do the Docker foo in the command line. This takes away a lot of that. Also allows you to search and discover new Docker images from the hub. They're all listed in the application, and integrate those directly into your local Docker instance. Super easy. So, first of all, thank you. Second of all, I wanted to tell you guys about the project that I do, and this is the reason that I had to learn all about Docker in the first place. This piece of software I build is called AzureCast, and what it is a web radio management suite. What it allows you to do, it's self-hosted, so it allows any radio station operator to go spin up a radio station from scratch on any server, even a $5 VPS from DigitalOcean, even the cheapest server you can imagine. Raspberry Pis will even run this thing. Very lightweight, but it depends on a bunch of different interconnected services that all have to be configured exactly the right way. And previously, when I was distributing this software, what I had to do is I had to give people a bash script that ran Ansible, and just cross my fingers and hope that all the software installed correctly, and a lot of the time it didn't. A lot of the time the VPS had some specific little quirk about its version of Ubuntu that was different from every other VPS's, and maybe the host doesn't quite have the right configuration, or maybe it comes with other packages that you didn't think of. Well, this takes all of that out, and it lets you build these beautiful pre-configured images that are exactly the way your software should be configured, and then your users just have to pull it down once. And if you update and you have new versions of that software, they can just update it. All they do is just pull down an updated image, and it's that easy. It takes a lot of the legwork out of having to build something that is capable of running on multiple different hosts. It also takes a lot of the support burden off of me. I found that when I switched to Docker for distributing this application, the number of support tickets went down dramatically of, I can't get this to install. Docker will install and everything will run. Now, whether you find the application useful after that, well, that's up to you. But getting it to install, that was a big problem point for a long time when I worked on this project. This project's been in development since 2012 in some shape or form. And it was just last year that I rolled out the Docker-based and Docker Compose-based version of this application, and it made a huge difference. And it was a big positive. So that's what got me wanting to talk about it and evangelize Docker a little bit myself. So yeah, hopefully hopefully the slides, when you actually get the slides, that gives you some good resources to go and play with if you're just getting started, or techniques on how to go further if you're already using it. So happy to answer any questions, or if anyone has any other thoughts.
Is there anything you have
it kind of, as far as I'm aware, it depends on how your application's built. But like Kubernetes configuration is different. Like the Kubernetes, the way it configures the containers is its own sort of style of YAML format. But full disclosure, I've actually never had a project big enough to need Kubernetes. Yeah, I've always had projects that are kind of right on the edge of like they're just popular enough that one server will still do the trick. And if you just throw more hardware at it, it's okay. And that's where I've been occupying my entire career is I've stayed in that little one server's enough for everybody world. And so I've never had to scale up. Kubernetes has been a subject of great fascination for me, and I'm waiting. One of the sponsors, since this is free and open source software, one of the sponsors is DigitalOcean. They give me a credit every year to work with, and they're about to roll out managed Kubernetes in their hosting environment, and the second they do, I'm playing with it. And I'm super excited. But yeah, as it is right now, I don't know a whole lot about it. So,
two questions. First off, for the Docker app side of things, what are you using in Docker Compose such that V2 is different enough from V3 that it's...
Oh, it's just little stuff. We've talked about this, Ian.
I forgot.
I complained to you specifically about this problem.
Yes, I recall you
Yes.
complaining, and I forget what the differences were.
So do I, actually. One or two little configuration options that are different, and really to explain to everyone else the disconnect here is that originally Docker Compose, the people who run Docker Compose, did not intend for 3 to be a sequel of 2. They intended for 3 to be for cloud environments, so Docker Swarm or Kubernetes. They intended for it to be like that, where it orchestrates multiple containers spinning up across multiple servers. And version 2 was supposed to be run locally and on these single server environments. They never told anybody that. We never got that memo. And so I just stuck using 2 for the longest time because I kind of inferred that the fact that they had taken away some configuration values and replaced them with others meant that that was where they were going. But finally, when someone asked them, why is one of these configuration values, and I think it was just like a simple one, like, do you put an initializer in front of it? It's some really, really small specific thing. They said, why is this not in Docker Compose 3? And finally, someone in the GitHub said, well, that's because Docker Compose 3 isn't the next one from Docker Compose 2. And everyone collectively said, we didn't know that. We thought it was the sequel. We thought, like, based on semantic versioning, 1 follows 2, Electric Boogaloo, and then, like, it went like that. No, in their heads, they had a whole different roadmap, but after somewhat of an angry crowd of Twitter people got to them, I believe they are now saying they're going to roll out all the features that were missing in 2 into 3, but it'll be in like later 3 versions, like 3.7. But they will be reconciling it so that 3 is a genuine superset of 2's features instead of a replacement that's different.
Okay. So my next question is somewhat related.
Sure.
Let's say I've gotten all of my crazy, gnarly, random Node app into a container because
Node things. Oh, don't say Node. Oh.
So that's the one. then we have a worker tier that reads off of Redis queue.
Sure.
That because Node, we have to run multiple of those workers. How would you set up either Docker Compose or something that's relatively lightweight and perfectly idiot-proof to run that environment where it's my database is going to be managed somewhere else. I don't have to worry about that.
Sure.
My queue is going to be managed somewhere else. I don't have to worry about that. I inject environment variables and I'm good.
Yep.
I'm going to have a volume now, whatever.
Yeah.
But my I need
You need more than
in a bunch of workers, and how do I
spin up and down the workers.
Yep.
So this is a problem actually that Docker is not itself well equipped to solve. So I have the same problem, right? How do you spin up new processes? And there are a couple of different ways that you can kind of hack around it with Docker. One is that you can give a container access to the Docker socket, which, big red alert warning, this also means effectively you're giving it root access to the server it's on, so really be careful with doing that. But you're it's a thing everyone ends up doing because like Docker doesn't really have this kind of management API that it needs. But yeah, so to you you can pass it the Docker socket and then spin up new Docker containers from inside of an existing one, or you can use something like Swarm or Kubernetes to do that, where they are actually suited to say how many instances do we want running. Really, Kubernetes and Swarm do a much better job of that than Docker does by itself. Or Rancher, yeah. Which, I mean, Rancher is Rancher. Yeah, they're all orchestration systems for this, so yeah.
Could that be a security concern if they're running on the same kernel that Docker gets attacked, then it can migrate itself over to
Yeah.
other Docker?
Yeah, absolutely. Yeah, this should be, and Docker at this point is best reserved for code you trust running, which it's quite safe running that environment. You know, running PHP code that you built or that you trust, you know, or that are common web applications out there, yeah, it's probably okay. But executing user-generated code and hoping that the sandboxing works, it's not meant as a security measure. It just happens to also be a security measure. It happens to be like a very bare bones, rudimentary like firewall built in, right? So an application can't connect in on ports that aren't directly mapped and directly exposed, and processes are supposed to be isolated from each other and supposed to be sandboxed. But by the very nature of the fact that they share the kernel, if the kernel has an exploit that allows for execution of privileges or escalation of privileges, so too does any Docker container running it. Yeah.
Do it have any chance to maybe make multiple kernels?
Well, what you,
As a matter of fact,
yeah.
Google has something called gvisor that does basically that. So you pull in, so Docker's normal thing is run C. There's run SC, which uses gvisor that insulates things the way you're talking about for that exact reason. And they couldn't actually roll out some stuff in Google App Engine until they got gvisor up and running because they couldn't get enough isolation to deploy an untrusted multi-tenant environment like App Engine with real code.
Yep.
So it's a thing.
It's one no, but it's basically no, just run my Docker container for me services.
Yeah.
The ones that do are Amazon kind of has one, Roku kind of has one.
Joyent has one because Solaris zones are a lot better at isolation than the chroot jails that Docker only uses.
Yep.
Sorry, Samsung that owns Joyent has one.
Samsung owns Joyent.
Samsung bought Joyent a while back.
So, following up on that, Linux background, does anybody know of any kernel work going on to improve Linux's, jailing capabilities to come, along the side of what Solaris zones was 10 years ago? I don't know. I'm not following the Linux kernels.
All I've really gathered from it is that the rise of containerization is definitely something the Linux kernel team is very aware of, and they have been working to adopt as many improvements as they can into the core of the kernel. Now, as far as security goes, that's twofold. There's some work to be done on Docker's side for that too, in terms of the fact that Docker, as it stands right now, if left to your own devices, and if you're running these images out in the wild, a lot of the time the user that's running in the container is root, is the root user. Now that doesn't really, it shouldn't be as scary as it sounds because it's the root for the container, not the root for the host. But they still need to work on a lot of that kind of stuff. Like you can configure it to run as a secondary user and to create a specific limited user account that runs the commands that run inside of Docker. That's totally possible for you to do. And recommended, really. But out of the box, by default, a lot of these programs do just run as root. And so then you really have to hope that you have to hope that you trust everything in the process and that there is no execution or escalation of privileges. So, yeah. Huh? Docker inside Docker is a very common thing. Yeah, as a result of this, so DND is what it's called. But yeah, no, Docker inside of Docker is very frequently used to manage, to do the thing that like Ian's talking about, to solve the problem that Ian's talking about of spinning up workers. Because if you really don't want the host to know anything about how Docker is set up, then even the thing running the Docker containers has to be inside of Docker itself. And that's where you're basically passing the Docker socket, which is how it manages Docker. You're passing it in as a volume into the container itself, where it then calls it and then executes. And basically it's so Docker in Docker is kind of somewhat of a misnomer, because what it does is it creates new containers beside it. It doesn't create new containers inside of it necessarily. That's a different thing. Like that's just nested Docker, like Matryoshka dolls.
To that, think if there's an escalation of privilege to protect the host system.
Do what?
If it has the socket to the.
Well, that's one of the reasons you're not supposed to do that, is because passing the Docker socket, the long and short of it is you can bind mount as a volume the root file system of the host. And in other words, if you bind mounted as a volume the root file system of the host in a user or in a container which then had root access, you're root for all intents and purposes.
Well, I think, is if you do Docker and then Docker, if you do it to Docker.
Well, sure. Presumably, right? Like it isolates it into the little like turtle that it's in, but I wouldn't count on it, is all I would say. This is definitely not something where running user code is, and this is the same reason that a lot of services depend on, if you see services that will run your own containers, they'll run them in Kubernetes. They'll run them as, Amazon has an elastic Kubernetes thing. Google is the pioneer behind Kubernetes. They're the people behind it, and they have their Google Cloud Engine, the Kubernetes version of that. DigitalOcean's about to roll theirs out. Really, a lot of web hosts are running Kubernetes because that lets you spin up those clusters with a lot better isolation.
But usually, even then, what they're doing for the Kubernetes rollouts is they're giving you a control plane and then saying, okay, you have to set up your own VMs. We'll help you, but you're running your containers on your own VMs.
Yeah.
We're just providing infrastructure around that.
They don't touch everything else. Yeah.
The only cases where that's not the case are, again, Joyent has their Triton stuff, which runs using Solaris zones, and now Amazon has Fargate. And my guess is you'll see, I think Google is coming out with something similar to Fargate as well, where they've figured out how to do enough isolation that they're okay with running a container multi-tenant, but it's not using the standard Docker run C stuff. It's adding another isolation in there that you don't normally see.
Yeah.
If you're not running Kubernetes, I'm just wondering, like, things which you can do to maybe use those Chef Ansible type tools, which can, like, for example, do things maybe that Fargate does, or these types of tools, especially in terms of like keeping things within, resource limits, like C-group type limits, because you don't want one guy to have a runaway, which starts hogging whatever network interface or something.
Yeah. At that point, what I would do is probably just entertain the existing solutions that exist, right? I just consider, I just switch to Kubernetes and just start, which, yeah.
No, they all must be, but like system D supposedly has something called machine CPL.
You can pass the secret flags to a Docker container.
Okay.
The daemon natively supports it.
Right,
So
okay.
you can tell it, even in Docker Component, you can say what memory share and what CPU share.
Nice.
So it is just raw features.
Yep.
Right.
And in fact,
So when Kubernetes does that, Kubernetes is just telling the Docker engine to do that.
So is there
Via
like
a web
a
interface.
cheat sheet of like, I don't know, like the 3-5 things that Kubernetes is doing, so which you can kind of do through Ansible or directly through Bash. And then, you know, if you don't need Kubernetes, then you can just get away without having to deal with it.
I think the best thing is just read the Docker Compose documentation because it's basically one giant file in every option possible.
Yeah.
I'm not sure you're gonna get like a zero downtime deploy out of it, but other than that, like it'll do most of what you want.
C groups and all that. Cool.
Yeah, in fact, I use the memory limit piece of Docker in one case where every once in a while this node app just goes crazy.
As they do.
Uses up all the RAM and then uses up all the CPU. It's a thing.
Really, with Node? No way.
Hopefully switching from Node 4 point something to Node 10 fixes that. But so what I did was set a memory limit of like 2 or 3 times what it normally would take up under normal operation. And then it's like, all right, if I do this, then the out-of-memory killer inside the container will kill the process. And then Docker, you can set a restart always flag.
Yep.
So Docker will resuscitate the process after the container has committed seppuku.
Yes. Cool. Thank you.